What about if we want to write scientific notation without using a calculator? You do this in 3 steps. In the first step, move the comma until there's only one significant figure in front of it. Step 2, you remove any insignificant zeros. You are now left with the digit term, which is capital N. You need to now count how many spaces you had to move the decimal comma to get it to that place where you've got it now, and that gives you the small n of the exponential term. For numbers 10 or larger, you'll have to move the decimal comma to the left. And for those numbers, n is positive. But for numbers smaller than 1, you'll have to move the decimal comma to the right. And for those numbers, n is negative. Let's take an example. Write 56,040,000 in scientific notation. So the first step is move the comma. At the moment, it's at the end. We don't write it, but it's sitting there at the end of all the digits we see there. And we have to then jump it all the way till behind the 5, so that there's only one digit before it. Now we remove any insignificant zeros. Now we don't actually know the measuring accuracy of the device that was used to measure this particular number, so it's not impossible that those zeros at the end might actually be significant. But definitely this zero inside the number is significant, so we can't go remove it. But let's assume that these last 4 zeros are insignificant, so we chop them off. So we now have 5,604. That is our digit term. Now, how many spaces did we have to jump our comma to get it to that position behind the 5? We had to jump it 1, 2, 3, 4, 5, 6, 7 spaces. That is now our exponential terms n. We had to move the comma 7 spaces to the left. So n is positive 7, or we just plain write 7. So in scientific notation, this number is 5,604 times 10 to the power 7. And you can see that that's correct, because what this is meaning is you must take the number 5,604 and multiply it by 10 to the power 7 to get the real number that we're speaking about. So if you were to multiply this number by 10 to the power 7, you'd have to jump the comma 7 spaces to the right. 1, 2, 3, 4, 5, 6, 7, and fill in all the zeros there, and then you can see we have the number we started with. Let's write 78,36 in scientific notation. First step, we move the comma until there's only one significant digit in front of it, 7,836. There aren't any insignificant zeros, so we don't chop them off. How many spaces did we need to move the comma to get it to its current position? We needed to move it 1 space to the left. That means that our exponential little n term is 1. So our answer is 7,836 times 10 to the power 1. Write 0,009007800 in scientific notation. First step, move the comma until there's only one significant figure in front of it. That means we've got to move the comma 1, 2, 3 jumps to the right to go behind the 9. We then knock off the insignificant zeros. Definitely those ones in front of the 9 are not significant. Those inside the number, between the 9 and the 7, have to be significant. And then those last 2 we don't really know. It depends on the measuring accuracy of the instrument we used, but let us assume that they aren't significant. And so we're left with 9,0078. How many spaces did we need to move the comma to get it to its position here? We had to move it 1, 2, 3 spaces to the right. So our exponential term n is minus, because we had to move it to the right, 3. So the answer is 9,0078 times 10 to the power minus 3. We can see that this is correct because what this is saying is the real number is 9,0078 multiplied by 10 to the power minus 3, in other words, divided by 1,000. And when you divide by 1,000 or multiply by 10 to the power minus 3, you jump the comma 3 spaces towards the left. That gives us the same answer, 0,0090078, that we started with.